Let's explore error handling in Express.js, a crucial aspect of building reliable and robust web applications. This presentation will cover the techniques and best practices for effectively managing errors in your Express applications. We will be focusing on Node.js and Express.js. There are primarily two types of errors that you will encounter in Express. The first type is synchronous errors. These errors are thrown directly within route handlers or middleware functions. The second type is asynchronous errors, which occur in promises and asynchronous operations. Understanding the difference is important for handling them correctly. Let us see how to handle basic errors. First, synchronous errors. To handle synchronous errors, you can use a try-catch block within your route handler. Here's an example. You define a route using apt-get for a path called /sync. Inside the route handler, you wrap the code that might throw an error like a risky operation in a try block. If an error occurs, it will be caught in the catch block, where you can then send an appropriate error response to the client, such as a 500 status code with a JSON payload containing the error message. Next, asynchronous or await errors. When dealing with async or await, the structure is similar. You wrap the await call of an asynchronous operation in a try block and catch any errors in the catch block. This allows you to handle errors that occur during asynchronous operations in a clean and predictable way. Let's discuss error handling middleware. Error handling middleware is a special type of middleware function that is designed to handle errors that occur during the processing of a request. The key characteristic of error handling middleware is that it takes 4 arguments: error, request, response, and next. Here's how to define and use a custom error handler. First, define the error handling middleware function. Notice that it has 4 parameters: error, request, response, and next. Inside the middleware, you can log the error stack trace for debugging purposes. Then you send a JSON response with an error message and status code. In a development environment, you might also include the stack trace in the response for more detailed debugging information. Finally, you register the error handling middleware with app use. This ensures that it will be used to handle any errors that occur in your application. Let's explore the concept of an asynchronous error wrapper. The async error wrapper is a utility function that simplifies error handling in asynchronous routes. It eliminates the need to repeatedly use try-catch blocks in every asynchronous route handler. Here's how you can create and use an async wrapper. Define the async handler function. This function takes a function, fn, as its argument and returns a new function that wraps the original function in a promise. When the wrapped function is called, it executes the original function with the request, response, and next objects. Any errors that occur during the execution of the original function are caught and passed to the next function, which is the error handling middleware. Here's how to use the async handler in your routes. Wrap your asynchronous route handler with the async handler function. This ensures that any errors that occur during the execution of the route handler are automatically caught and passed to the error handling middleware. Let's see how to create custom error classes. Custom error classes allow you to create structured error types that provide more context and information about errors in your application. By extending the built-in error class, you can define your own error classes with specific properties and methods. Here's how to define a custom error class. Create a class that extends the built-in error class. In the constructor, call the superconstructor with the error message. Define any additional properties that you want to include in your custom error class, such as a status code or an isOperational flag. Now let us see how to use a custom error class. When an error occurs, throw an instance of your custom error class. This allows you to provide more specific information about the error to the error handling middleware. Now let's talk about centralized error handling. Centralized error handling involves using a global error handler middleware to manage all errors in your application in a single place. This approach provides a consistent way to handle errors and simplifies error logging and reporting. First, let's create a global error handler middleware. This middleware function takes 4 arguments: error, request, response, and next. Inside the middleware, you can log the error for debugging purposes. Check if the error is an operational error, which is an error that you expect to occur during normal operation. If it is, send a JSON response with an appropriate error message and status code. If the error is not an operational error, log the error and send a generic error message to the client. The final step is to register the global error handler middleware with app use. This ensures that it will be used to handle any errors that occur in your application. Let's look at some of the best practices to follow in error handling. In error security, never expose stack traces in production, log errors for debugging purposes, and use environment-specific responses. Next is error management. Always use async error wrappers, create meaningful error messages, and handle unhandled rejections. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.